A spacecraft has made contact with the Sun, for the first time in history. NASA's Parker Solar Probe has sampled particles and magnetic fields in the Sun's upper atmosphere, known as the corona. The new milestone is a significant step forward for Parker Solar Probe, and a giant leap forward for solar science. Parker Solar Probe was launched in 2018 to investigate the mysteries of the Sun, by traveling closer to it than any previous spacecraft had, facing brutal heat and radiation conditions, to provide humanity with the closest ever observations of a star. Parker has finally arrived 3 years after its launch and decades after its conception. The Sun, unlike the Earth, lacks a solid surface. It does, however, have a superheated atmosphere made of solar material, that is gravitationally and magnetically bound to the Sun. As rising heat and pressure push the material away from the Sun, gravity and magnetic fields become insufficient to keep it in check. At closest approach, Parker Solar Probe hurtled around the Sun at approximately 430,000 miles per hour, or 700,000 kilometers per hour. At closest approach to the Sun, the front of Parker Solar Probe's solar shield faced temperatures approaching 2,500 degrees Fahrenheit, or 1,377 degrees Celsius. And to withstand that heat, the probe makes use of a heat shield, known as the Thermal Protection System, or TPS, which is 8 feet or 2.4 meters in diameter, and 4.5 inches, that is about 115 millimeters thick, carbon composite shield. Those few inches of protection mean that just on the other side of the shield, the spacecraft body sat at a comfortable 85 degrees Fahrenheit, or 30 degrees Celsius. However, the TPS does not have all of the Solar Parker Probe equipment. The Solar Probe Cup, which protrudes over the heat shield, is one of 2 instruments aboard the probe that are not shielded by the heat shield. This device is a Faraday cup, which is a sensor that measures ion and electron fluxes, as well as flow angles in the solar wind. The cup is built of sheets of titanium zirconium molybdenum, a molybdenum alloy with a melting point of 4,260 degrees Fahrenheit, that is, 2,349 degrees Celsius. The grids that generate an electric field for the Solar Probe Cup are constructed of tungsten, a metal with a melting point of 6,192 degrees Fahrenheit, or 3,422 degrees Celsius. Normally, lasers are used to etch the grid lines in these grids, but acid had to be used instead, due to the high melting point. Another issue was the electronic wiring. Most wires would melt if they were exposed to heat radiation at that close range to the Sun. The researchers used sapphire crystal tubes to suspend the wiring, and made the wires from niobium to overcome the problem. Scientists needed to simulate the Sun's high heat radiation in a lab to make sure the equipment was fit for the tough environment. They used a particle accelerator and IMAX projectors that had been jury-rigged to boost their temperature to achieve a test-worthy level of heat. The projectors imitated the Sun's heat, while the particle accelerator exposed the cup to radiation, in order to ensure that the cup could monitor the accelerated particles under extreme conditions. The Solar Probe Cup was tested against the high solar emission in the Odiolo solar furnace, which concentrates the Sun's heat through 10,000 movable mirrors to ensure it would withstand the extreme environment. However, being so near to the Sun necessitates much more protection. The cooling system for the solar arrays is surprisingly simple. A heated tank stops the coolant from freezing before launch, 2 radiators keep the liquid from freezing, aluminium fins increase the cooling surface, and pumps circulate the fluid. The cooling system is powerful enough to cool a typical living room, and it will keep the solar arrays and equipment cool and functional while in the heat of the Sun. But what is the system's coolant? It is deionized water, about a gallon, that is, 3.7 liters. While chemical coolants are plentiful, the spaceship will be exposed to temperatures ranging from 50 degrees Fahrenheit, or 10 degrees Celsius, to 257 degrees Fahrenheit, that is, 125 degrees Celsius. Water is one of the few liquids that can withstand such extremes. To keep the water from boiling at greater temperatures, it will be pressured to a boiling point of over 257 degrees Fahrenheit, or 125 degrees Celsius. The spacecraft is programmed to stay safe and on course for the Sun on its own. Several sensors the size of a cell phone are connected to the spacecraft's body at the heat shield's shadow's edge. If any of these sensors detect sunlight, they warn the spacecraft's central computer, which then adjusts the spacecraft's location to protect the sensors and the rest of the equipment. All of this must occur without the need for human intervention, thus the central computer software has been programmed and thoroughly tested to ensure that all necessary modifications can be done on the fly. Parker is finding new discoveries that other spacecraft couldn't observe because they were too far away, including from within the solar wind, which is the flow of particles from the Sun that can affect us on Earth. Parker revealed in 2019 that magnetic zigzag formations in the solar wind, known as switchbacks, are abundant near the Sun. However, it remained a mystery as to how and where they formed. Parker's solar probe has now traveled close enough to identify one spot where they originate. It's the solar surface. The spacecraft will orbit our star 24 times throughout the length of the projected 7-year mission. It will sample the solar wind, investigate the Sun's corona, and offer unparalleled close-up views from around our star on each close pass. Touching the very stuff the Sun is made of will help scientists uncover critical information about our closest star and its influence on the solar system, just as landing on the Moon allowed scientists to understand how it was formed. The first flyby into the corona, and the promise of many to come, will continue to deliver information on processes that are difficult to examine from afar.